Okay, so I think we'll start. Good morning, everybody. I'm Hagit Kai, and together with Dominic Clark, I'll be chairing the technology sessions. And the first speaker of the day is from EBI, and it's Fabio Madeira, and he'll be talking about EBI tools. Go ahead.
Right, good morning, everyone. Thanks for the introduction. So I'll be talking about EMBL-EBI tools as a service, and I'm, of course, from EBI. I'm part of web production. This is a team at EBI which is responsible for web infrastructure and core web services. There are two main projects that are provided by web production. One of them is, of course, the one that I'll be talking about, the tools framework. The other one is the one that Youngmi will be talking next, so you might want to stay for the next talk as well. She will be talking about the EBI search. So these are the two main projects that are provided web production. This is the team, and this is the group is headed by Rodrigo Lopez. So the talk today, I'll be giving you an introduction to the tools framework, job dispatcher, and I'll give you some, an overview of the tools and databases that are provided. I'll give you then an overview of the API, the web services API, as well as some example of sequence analysis workflows that you can put together by using our web services. So Job Dispatcher, the tools framework, provides fully integrated access to core bioinformatics applications. So these are the sort of powerhouse applications in bioinformatics, like ranging from Cluster, Omega, like this kind of tools. For example, multiple sequence alignment tools and sequence similarity search tools as well. And of course, we also provide, with these tools, access to updated biological databases. And many of them are hosted from EMBL-EBI data resources. So if you want to actually, if you are wondering where you can actually access these tools, so if you add to EBI's website, there's many places where you can actually try and find the tools. And of course, for example, if you know the name of the tool that you want to use, you can actually just type that into the search box there. But if you go to services at the EBI website, so this is the page that you would be looking at. And from here, you can find all the tools as well as the other data resources. And again, you can also type in the name of the tool if you know that. So this is how our tool page looks like, the web interface. And so for example, in this case, we are looking at the Cluster Omega page, and you can see pretty much all tools the web interfaces will be looking the same or very similar. And typically, there's an input box where you would type in some sequence identifiers, or you could just paste in sequences in a variety of different formats. And there's an option, of course, as well to upload a file. Just to give you an idea on the kind of applications that we provide with the tools framework, we provide from pairwise to multiple sequence alignment programs. So the examples would be, for example, Cluster Omega, MAFT, Muscle, T-Coffee, and so on. We also provide sequence similarity search applications such as CBI Blast Plus, FastA, SciSearch, and SciBlast, as well as Hummer, HMM Scan, and PMer. And we also provide other tools such as InterProScan, which are quite popular, quite widely used, PFAM Scan, for example, as well, and also a lot of tools from the EMBOS suite of applications. So just to give you another example of how a web interface looks for another tool, in this case, CBI Blast. And the main difference in this case would be that you have an option to select databases. So if you are doing, in this case, a sequence similarity search, you would need to search against using some database or a combination of databases. And that's really the main difference between these two web interfaces. So just to give you, again, an idea over the sort of databases that we provide. Of course, we provide protein sequence databases from the UniProt knowledge base. For example, we provide the UniRef, UniParc, reference proteomes databases. We also provide nucleotide sequence databases, for example, ensemble genomes and worm-based parasite genomes as well. And we provide also pretty much all the release and update ENA sequences as well. We provide sequences from macromolecular structures from the Protein Data Bank in Europe, and also other specialized databases, for example, the IPD, IMGT consortium of databases, for example, Campbell, Intact, and so many others. So this just to give you an idea over the sort of applications as well as databases that are provided within this tools framework, Job Dispatcher. So we provide, alongside all the tools, we provide comprehensive open documentation as well as some FAQs. And I will show you in a couple of slides also an overview of the API web interface that we provide that you can use to explore how to use the services programmatically. So this is just a screenshot of the documentation, the home page for the documentation. From here you can find a lot of information about the different tools, and you can actually use the left navigation bar to find out, and just to to click on the tools, on the help pages for the tools that you might be interested in. And for all of these tools, we provide a section in those pages related to programmatic access on how you use the services programmatically. You might also want to view the webinars that we have recorded over the time, which are quite useful if you want to use our services. So now I'll just give you a very brief overview of the Web Services API. So Job Dispatcher provides web services interfaces to the service. We provide RESTful and SOAP web services. So in this page here, you would be able to navigate and basically get an overview over the different endpoints that we provide. And it's common, the page is actually common throughout all the different tools. So in this drop-down, you would be able to select a particular tool, and from there, in this case, I'm just selecting, I think, Cluster Lambda, yeah. In this case, you would be able to see the available endpoints, and pretty much the endpoints are the same for all different tools. So in principle, if you know how to use one of you know how to use the API for one of the tools, it would be the same for all the other tools. And of course, different applications will take different parameters and different fields. So you can learn all of that with these endpoints. For example, the first one, which is the / parameters. With that endpoint, you would be able to find out all the parameters that a particular tool take. And you can get to know more details about these parameters. And you can even try to submit a job with the post request there. And this would be a nice way for you to actually understand what kind of required parameters you would need to pass. For example, in this case, typically you would need to pass some input sequences or sequence identifiers. That's obvious as a required parameter for running any of these applications. And you can actually use the try on button on the bottom there to actually submit a job and see whether there's any errors with the values that you pass to the fields. So, for example, when you click on the try on, you can actually see an example of a curl command that you would, for example, want to try in your own command line prompt. And pretty much, you can also see down there, also in the bottom, the response that you would get from the services. In this case, I think the one we are trying here is just the parameter. So it's literally at least gives you back a list of different parameters that, in this case, Cluster Lambda would accept. So, of course, with the other endpoints, you can get to know more about this. And you can actually, once you submit a job, in this case, to run a Cluster Lambda in our service, you would also be able to check the status of that job, whether it would be finished or still running. And you could also check, for example, the various result types that are available for that particular job. So as I said, Job Dispatcher, the tools framework, provides software as a service capabilities because it provides these programmatic access via REST and SOAP web services. And just to give you an idea over the advantages you might have using our tools framework. So in a typical bioinformatics setup, for example, you can see on the left, usually if you wanted to run one of these applications, bioinformatics applications, you would basically download the software, install it, and install the dependencies. And for example, if you are working with a sequence similarity search tool such as BLAST, you'd also need to set up or download databases and set them up. And of course, as you are aware as well, some of these applications get updated quite frequently, and the databases as well. For example, if you are working with UniProt databases, every month there will be a new release. So if you were to maintain these on your own machine, on your own environment, it's quite a lot of work just to keep everything updated. So an advantage, of course, in this case, if you use our services, is that you can download clients that we have pre-made in a variety of different programming languages, and you can literally just install the dependencies for these clients, and you'd be ready to go and start performing some analysis, submitting your analysis to our service. Another way would be also to use a Docker image that we provide with the pre-installed clients, or using workflows that I'll show you more in a couple of slides. But essentially, with this approach, you could just literally do a Docker pull of the image or just download the workflows. I will tell you more about those. But essentially, yeah, in that case, you'd just be able to submit your analysis quite easily, and you would not need to maintain any of these infrastructure in your case. In this case, we do that for you. So we keep the applications updated. We keep the databases updated as well for you. So just to give you an example of integrations, and just to say that the service is actually quite widely used and widely visible. We just this year so far, we run already around 300 million jobs, which is quite a number. So you might have used for example, in this case, Uniprods or PDB, they provide this function where you could just do a blast or just do a sequence similarity search. And in fact, they are using the tools framework underneath. The same for Interpro with their Interpro scan, and the same for ensemble genomes. Just to give you some examples of integration in this case, these data resources at the EBI already use our tools framework. You can also use that. So hopefully I'm able to convince you that it's a good idea to use our web services and use the services programmatically. And just to finish off, I'll just give you a set of examples of workflows that you can put together. So you can actually put all these services together in more complex sort of analysis pipelines. So just before that, just to point out that you can download these basically pre-developed command line applications that you can easily download and use. The very easy way for you to get into running our services programmatically, you could just download these clients from our GitHub repository that you can see the link there. And we basically actively provide at the moment Python, Perl, and Java clients for the REST service, but we also provide some other sort of older clients for SOAP web services and for REST in other languages as well. Anything from Ruby to C#, for example. So we also provide a common workflow language description files for the clients, as well as some example CWL workflows. If you are not aware of CWL, CWL stands for the Common Workflow Language, and is sort of a common specification that's becoming more and more popular now. That allows you to describe, analysis workflows. So you can basically describe a set of steps that your analysis will take with CWL. So we provide basically CWL files for the clients, sort of wrappers to the clients, but we also provide sort of ready-to-use examples of fully made analysis workflows. So I will just give you now 3 examples of what those would look like. So in this case, for example, just a quite basic workflow with 2 steps. So in the first step there, we've literally just got a single file with a set of sequence identifiers. And with dbfetch step, dbfetch is a tool that we provide to basically, that allows you to do data retrieval, or just basically you can retrieve sequences in a variety of different formats. So in that first step, we basically retrieve the sequences in FASTA format, and then we run HMM scan step. So this is just a 2-step workflow, just to give you an idea. And this is basically been set with the CWL, so you can use, you can basically go to our CWL repository in GitHub and download these. And we also provide an inputs file that you can use alongside. So just another example of a workflow that you might want to use. So for example, in this case, we are doing an NCBI blast. To start with, we get a list of hits. We get a list of sequences that are homologous to our query sequence. Then we use dbfetch again to download the sequences, and then we can run, for example, a multiple sequence alignment program like LSOLOMGA. And once we got a multiple sequence alignment, we can also generate a phylogenetic tree, and that would be the last step. So this is just a simple sort of a commonly performed bioinformatics analysis workflow with 4 steps. Just another example here where we run a blast and we do some conversion of the output, and we use, for example, in this case, EBI search API to get a list of cross-references for the hits that we get. And for example, some of these cross-references are actually PDB entries, and we could use the PDB API, for example, to get a summary of what these entries might be. Just to give you another example. So I think this is pretty much what I wanted to talk about today. So just to give you here some links. So I already mentioned the services page where you can find the tools. I mentioned the documentation as well. This is the URL you would go In that page, you can find all the information about all the different tools and how to get more information about the programmatic access, and also just the two links at the bottom, just where you can download the clients and the CWL files from our GitHub organization repositories. So if you need any other help, if you get stuck, or if for example, you are setting up some CWL workflow or something like that, you might contact us anytime. We'll try to help you as much as we can. So you can use the support page at TBI's website to do that. So just to finish off with some acknowledgements to web production, the entire team that makes this work possible, and of course, if you use our web services, we would be really happy if you could cite our latest publications. And that's really, thanks for your attention as well. If you have any questions. Right, that's good. I think, yeah.
Could you pass the mic?
Thank you, Fabio. Very interesting, very impressive set of services. Just a very simple question. You referred to REST and SOAP services. Apologies if you answered this and I missed it, but as an end user, REST is good, SOAP is bad. Do you have any strategy for getting off SOAP services?
You can, yeah, we still provide the SOAP, but of course we are promoting more the REST now, because I think we, at some point next year or so, we might actually just drop SOAP supports. That was the reason. But I mean, yeah, sorry. We also provide some help over in the programmatic access part, so it would be easy for you to just get there and see how you integrate the services with the SOAP. Yeah. Yeah.
So, for example, how robust is the API, for example, if I want to submit like a batch of millions of variants to get annotated with?
Yeah, so we don't have any sort of requirements or limits, but of course we encourage users to submit like a batch of 30 jobs at a time, wait for the results, and then submit another 30. For example, if you want to do 1 million, then of course you'd basically, ideally you'd want to have some way in your script, a way of just pacing the submission of those. But in any case, if for example you'd submit those 1 million at a time, the jobs go to a queue, and of course basically they will only run whenever there's enough slots in our.
For each variant, for example, like one request.
Yeah, in that case you need to request literally 1 million jobs, essentially. But yeah, I mean some of the clients, for example, if you want to do, say that you want to do a sequence similarity search, and you've got a list with say 1,000 of sequences that you want to search with. In that case, you can use sort of a batch flag that we've got in the clients, where you would just basically input that file, and it would do the submission for you in this timely manner. Like it would do the 30 sequences first and then carry on. So in that case, you would not need to do any of the sort of bash handling yourself. The client itself does it for you, but it depends a bit on the actual tool that you want to run. If it was a multiple sequence alignment tool, for example, in that case, we don't provide that batch mechanism in the clients, so you would need to sort of handle that yourself.
Thank you. It looks like you're using OpenAPI for your REST web services.
Yeah.
Did you develop any kind of automated translation to generate the CWL tool descriptions?
Yeah, so we basically, the framework itself works with an XML description of the tools, but we basically made we made some function literally that generates CWL out of our XML basically specification, and from there we can actually we are actually generating CWL as well as the clients from the open API, the JSON descriptor of a tool. Yeah, we do have I think it's actually public in our repository, in our GitHub page as well. We have got some generators for both the clients as well as the CWL. Yeah. So you can actually have a look on those. It's just some quite small Python, just takes our open API JSON and basically template-based CWL generation. Yeah.
Okay, thank you very much.
Thank you.
Okay, our next